Traveling to the moon is much faster than going to Mars. A trip to the moon takes about 3 days. But Mars is far away and the journey takes a lot longer, about 2 to 3 years. It's a big difference. The challenges of going to Mars are also much bigger. Astronauts will be away from family and friends for a long time. The mission will be tough, but it's exciting to think about visiting another planet.
The time needed for a Mars mission is much longer than the Apollo missions to the moon. While Apollo 17, the longest mission, lasted only 12 days, a trip to Mars could take a couple of years. Being away from Earth for so long can be difficult. Astronauts have to face a lack of sunlight, the same food, and no real day or night for a long time. It's a test of both body and mind, but it's an important step for us.
Radiation is a huge problem when traveling beyond Earth's atmosphere. On Earth, our atmosphere and magnetic field keep us safe from most harmful rays. But in space, astronauts face a lot more radiation. For example, on the International Space Station, they deal with 250 times more radiation compared to Earth. This is already high, but going to Mars could mean up to 700 times the radiation without our planet's protection.
That's right, and higher radiation levels are not the only problem. The ISS is within Earth's orbit, so there's some protection. But a trip to Mars means facing these dangers head-on. This is why scientists are studying the effects on astronauts' bodies when they spend time in space. For instance, NASA and the ESA have ongoing studies to help understand what happens to humans during long space missions.
One of the famous studies was with the Kelly twins. Mark stayed on Earth while his twin Scott spent a year on the ISS. They looked at changes in Scott's body and health during and after his time in space. One big finding was about his telomeres. These are parts of DNA that usually get shorter as we age, but Scott's actually got longer in space, which was really interesting.
Yes, the study gave us many clues about how space affects us. It showed that space travel might have unexpected effects on our bodies. NASA and ESA use these findings to plan for future Mars missions. Understanding changes like in gene expression helps create better health plans. With long missions, we need to know how to keep astronauts healthy and safe. These findings guide us as we prepare for the challenge of Mars travel.
Let's dive into the psychological challenges of traveling to Mars. People have been part of simulated Mars missions to understand the mental demands of such a long trip. They had to deal with isolation, limited resources, and feeling cut off from Earth. These tests help us learn about how people might react on a Mars trip. It's almost like being on a different planet right here on Earth.
Exactly. One notable study is the Mars 500. It was done with partners from Russia, Europe, and China. 6 people lived in a simulated Mars environment for 17 months. They worked together in close quarters, which helped study how such a crew could cooperate. The diverse mix of cultures and personalities provided insights into team dynamics and how to resolve conflicts.
Sleep is another tricky part of these long missions. Without natural sunlight, it's hard for people to keep a regular sleep schedule. In the Mars 500 study, the participants found their sleeping patterns changed. They often had trouble staying awake and alert. Having no natural day or night makes it harder to perform tasks. As the mission continued, the crew tended to sleep more.
Yes, disrupted sleep can affect how well the team works together. It's crucial to maintain team cohesion, especially in stressful situations. The studies show that good teamwork can make a big difference. Learning how to solve problems and handle disagreements is key for a successful mission. These psychological insights are vital as we prepare for real journeys to Mars.
Living on Mars requires the same basic things we need on Earth, like air, water, food, and a place to live. Oxygen is super important because it's what we breathe. Without a regular supply from Earth, people on Mars need to find ways to make it themselves using what's found there. Water is needed too, but it must be collected and cleaned because Mars is not like Earth where we have water everywhere.
To make oxygen and get water, scientists look at Mars's resources. One project, called MOXIE, is trying to produce oxygen from the carbon dioxide on Mars. It's a small device but works well on its own. With more power, it can support a little home full of air. Water on Mars is mainly ice, locked in polar caps or underground in caves. People need to find this ice and make it drinkable using special technology.
Finding water on Mars is not easy. The water there is frozen, often mixed with salty stuff that we can't drink. But we need water not just to drink, but to grow plants and maybe make fuel. Scientists think they can use Earth technology to get water from the ice on Mars. They can also try to clean and make it safe so people can drink it or use it for other things.
To clean water on Mars, special filters might be needed. These can take out harmful salts and purify the water. Sometimes, science uses good bacteria to help this process work. While these plans sound hard, it's very important. Without cleaning the water, it cannot be used safely by people or plants, so learning to clean Mars water is a big step in living on the red planet.
Producing fuel on Mars is very challenging yet important for missions. Without fuel from Earth, we need to make it ourselves there. Some chemical processes can help create rocket fuel. They can also produce water as a byproduct. If we can manage these processes, we might have enough fuel to power rockets and support other energy needs on Mars.
Electrolysis is one way we can use Mars's resources. By using electricity, we can split water into hydrogen and oxygen. This can give us breathable air and fuel. But the low gravity on Mars and very cold temperatures make this harder. We must find ways to do it efficiently so that we don't waste energy or other resources, which are limited on Mars.
Low gravity on Mars presents more challenges. Everything behaves differently when there is less gravity. Machines might not work the same way as on Earth. Also, the reaction times for chemical processes could be different, affecting how fast or slow we can produce fuel. The temperature is very low too, which can slow down reactions even more.
Efficiency is a big concern on Mars. We need the processes to work well to conserve energy. If machines aren't efficient, we'll run out of power quickly. Finding the right balance in these tough conditions is key. We need to test and adjust our systems and processes to make sure they can handle the environment, providing consistent fuel and energy.
Growing food on Mars starts with experiments using LED lights. These lights help plants grow without natural sunlight. It's called hydroponics and means growing plants in water with nutrients, not in soil. Scientists are testing this method with Mars soil simulants, which are materials that mimic the real soil on Mars. This helps in understanding whether plants can get the nutrients they need to grow on Mars.
Hydroponic methods are very promising because they use less water and space. This means it's possible to grow a lot of food without taking up much room. Mars has soil, but it's not the best for growing food. Researchers mix the Mars soil with things that plants like to see if it helps them grow. They also study how much light from LEDs plants need to be healthy and strong.
Cyanobacteria are tiny creatures that can survive with very little resources. Studies show they might help us grow food on Mars. We are testing these bacteria by mixing them with Mars-like soil. So far, they have shown they can live with limited sunlight. This could be key in creating a source of food and oxygen on Mars. The tests are promising because cyanobacteria can make the soil better for growing other plants later on.
Vertical farming and aeroponics are ways we can efficiently grow plants for Mars missions. Vertical farming uses layers of shelves to grow more plants in a small space. Aeroponics takes this further by hanging plants in the air and misting them with nutrients. These methods are smart because they save water and don't need heavy soil, which is hard to transport. This approach may help us grow enough food to support people living on Mars.
Building a safe home on Mars isn't easy. A good idea is to use reinforced inflatable habitats. These can be quickly set up and then covered by strong materials to protect them. This cover is important because it keeps out danger like radiation and helps to maintain a good temperature inside. Living in these would help astronauts stay safe while they are on Mars.
Scientists have come up with an interesting new building material called starcrete. It's made by mixing starch with Mars-like soil. This concrete is very strong, much more than the concrete we use on Earth. By using the things we have on Mars, like the soil, we can build strong and safe places for people to live. It's a smart way to use what's already there.
Mars has some natural places that might help us too. Caves and lava tubes found on Mars could be used as shelters. They offer natural protection from the weather and radiation. Before moving in, we need to make sure these places are safe and stable. This means checking that the walls won't fall and that they offer good protection for people living there.
Checking the safety of caves and lava tubes is very important. We need to ensure they don't collapse, especially during Mars's small earthquakes. Using these natural shelters could save a lot of time and resources. Plus, they offer extra protection from radiation. By having both natural shelters and built habitats, we increase the safety and comfort of living on Mars.
Please show us your support by liking and subscribing to our podcast. Stay tuned for more fascinating space content and updates on future Mars missions. Your support helps us bring more exciting stories and information about space exploration. We can't wait to share more with you.